All right, we're back here doing 5-7. We're going to be solving quadratic inequalities. And in this case, we're going to be drawing parabolas. And remember, when it's just less than or greater than, we'd use a dotted line. And if it's less than or equal to or greater than or equal to, we use a bold or solid line for drawing the parabola. And remember, greater than is above, less than is below. And so we can certainly graph these. Going ahead, let's go ahead and put that into Desmos, and you can kind of see what happens. You just type that in as you see it. You can see, yeah, it shades it right above there. You see the solid dot line. It works out fantastic. Can't say enough good things about Desmos when you do those. So we'll come back to this in just a little bit on doing some of those drawings. So that works out really nice on being able to use that. Again, now remember this one, if it's less than, excuse me, we're going to have a dotted line. And then again, if it's less than, we're going to shade below the parabola. And again, if you type it in Desmos as you see it, it'll do all the right things as far as solid dotted lines and shading. All right, let's try to use the graphs and tables to do this one. We're going to type it in two ways. We're going to type in, if we're doing the graph, let's type in x squared plus 8x plus 20. All right, so we have x squared plus 8x plus 20. All right, then on the second one, so that gives us our parabola. And we're going to know when is it greater than or equal to 5. So we'll just type in y equals 5. That kind of gives us that horizontal line. Oh. So really what we're looking for is when is the parabola greater than that red line? Well, anytime it's less than -5, right? Okay, then it's above. And then, or anytime that it's x is greater than -3. So there's our solution to our problem on the graph, okay? Anytime we're less than -5 or x is greater than -3, it's a disjunction, right? We have two different parts of the graph. What we're looking at here is we're shading this part right here and this part right here. So that's an or. There's two different parts to that we want to look at, okay? All right, we'll come back to that. So we have that. That's good. Yeah, you can kind of see what we're talking about there as well. All right, there it is. All right, now let's do this. When is x squared plus 8x plus 20 less than 5? Whoops, let's go back up there. So we're just going to change this up. So it's the same graph. Once again, this time we're looking at when are we less than? All right, well, we have those same two intersection points, but now what we're asking for is when are we below 5? Well, that's when we're here and here, right? All right, so let's go ahead and do that. So it's when we're in between. So this is going to be an and, right? That conjunction. So when x is in between, when it's greater than -5 and when it's less than -3. That's how we can do those. Okay, by graphing that, we can see that. All right, let's try this one again using tables and graphs. X squared minus x plus 5. So let's do that. X squared. All right. Oh boy, I got to get my little thing back up here. Let's see if we can do that. Let's get that. There we go. X squared. Make sure I got that. Minus x plus 5. X plus 5. Whoops, I got that wrong, didn't I? Minus x plus 5. There we go. All right, and so now again we're going to be at 7. 7 is going to be the thing there, so we're going to go y equals 7. That's going to give us that line. So we want to know when is the parabola below 7. All right, well, a couple things. It's when we're in between here and there. So it looks like we're below 7 when x is between -1 and 2. So we'd say when x is greater than -1 and when x is less than 2. It's a conjunction because it joins in together when we do that. Okay, so there we go, using tables and graphs. Now let's use algebra this time. Now if we're going to use algebra, we can do the same thing. Now let's get everything over to one side. So we're going to get x squared minus 10x. If I add the 3, it's going to be plus 21. We want to know when is that less than or equal to 0. So here's what we have. We have an upside opening parabola. We want to know when is it below the x-axis. So what we got to do is we got to find these points right here, and it's going to be an and. It's going to be in between. So if we factor x minus 7 and x minus 3, those are two numbers that multiply to 21, add to -10. And so our zeros are going to be 7 and 3. So here we go, 3, 7. So what we'd say is when the parabola is below, that is when x is greater than or equal to 3, but less than or equal to 7. That's the and. We'll see that conjunction. We'll see it written like that, like a little sandwich is what we have there. All right, let's try another one here. Again, using algebra, let's get everything over to one side. Let's see, we've got x squared minus 6x. If we subtract 2, we get plus 8, is greater than or equal to 0. So once again, we have an upward opening parabola. This time we want to know when are we bigger than 0. So it's when we're here or when we're here. So this is going to be the disjunction here. So let's factor x minus 4, x minus 2. Those are two numbers that multiply to 8, but add to negative 6. So our zeros are going to be 4 and 2. So this would be, our solution would be, it's when x is less than or equal to 2, or when x is greater than or equal to 4. So algebraically we can solve it. We can also use the calculator to do that as well. All right, so there we go. Try a few of those. That's 5-7. Until next time, I'm Mr. Boone.